Hello and welcome back. Now that we have our initial game setup complete, various clients can connect to the server. The server sends over game setup configuration, then the server sends a specific player object to an individual client, and lastly broadcasts to all connected clients the game state whenever a new player joins. That's all working wonderfully. So now we can work on advancing the game to our next game state. So we can see, I won't run it again, but we saw that when the correct number of players joined the game, our status message on the game screen changed. We were prompted to press enter. So we want to press enter to send a signal to the server that, hey, we as a client are ready to play. And when all clients have signaled that they're ready to play, the server is going to send us back some information starting the game for us. So pressing enter. This is a key press event. And so where do we look for Pygame events? Well, we look in our main game loop because that's where we're emptying out the event queue. So I'm going to scroll down to our main game loop. Here is our main game loop, and you can see right here for event in pygame.event.get, we are emptying out the event queue. And we're checking right now to see if a given event is of the type quit. And so that's great. But now we also want to check to see if there is an event of type key down. So if someone pressed a key. So we'll say if event.type is equal to pygame.keyDown, someone pressed a key, we now want to see what key was pressed. All right, we're telling the user that they should press enter in order to advance the game. So we'll say if event.key is equal to pygame.k_return. Return. Make sure you spell it right. So Pygame calls the enter key return. So that's how we'll check to see if the user is pressing a key. If it is the enter key, what do we then want to do? Well, we want to make sure first that we put some checks in here. We only want to advance to the next state of the game, signaling that maybe the player is ready to play, if the player is currently waiting. So we have a flag is waiting. So we're going to say if the game has not yet started, so that means there is waiting flag is set to true, and all players are in the game. We want to make sure that all of the players are in the game before we advance. So we'll say if my player, that's what we're outside of any class right now, so our player is called my player. So if my player dot is waiting, and my game, so our game object, if you recall, our game object has a player count attribute. If my game.player count is equal to the game's total players, so my game.total players. So that means everyone is in the game. Well, what should we do now? Well, I think our game has a method called readyGame. That will indicate that we are in fact ready to play. So let's call that method. We'll say mygame.readyGame. And we should go write the readyGame method right now. So I think we got to scroll up for readyGame. We just have to find it. So if I scroll up, scroll up. readyGame is right here. So here is our readyGame. So if the player hits enter under the right conditions, then we are going to signal that they are in fact ready to play the game. Thankfully, we have lots of attributes to our player to help with this, and these are going to be our Boolean flags. So let's look at them now. We've got a is waiting and is ready flag. We got to change those. So we're going to say update status flags for the player. So to ready the game, we're going to say self.player. We're inside of the game, so we're going to reference the player object, and we're going to take its is waiting flag. The player is no longer waiting. We're going to set that to false. The player is ready to play the game. So we'll say self.player.isReady, and we'll set that to true. And let's also change the status message of the player to like a useful message here. So we'll say self.player.status underscore message is equal to ready waiting for other players. So we'll say we're just waiting. You're ready, but we got to make sure everybody is ready before we start. So now we've changed the player's state on our client side, right? We've updated some player flags. What we now have to do is we now have to send this changed state over to the server so it can be processed. And thankfully, we have a method here on our client side called sendPlayerInfo. So what we need to do is we'll call send player info, send specific info about this player to the server. We'll call this method and send over these changes. So inside of ready game, we'll end it here by saying send updated status to the server. So we'll say self.send player info. And I guess we're here. We might as well write send player info next, right? In terms of our logical progression of what we need to do, that's the next thing. So I'll scroll down to send player info. We'll get rid of our pass here, and then let's write this method. So we'll start by saying we're going to create a dictionary of pertinent items to send over to the server, the things that will potentially change from our player. And really, what's changing is their coordinate and their status flags. I don't think here there's no need to send the whole player object over, so we're not going to do that. We'll build our own dictionary. I think it'll just be a little easier. So we'll say create a dictionary with items to send, and so we'll call this dictionary player info. And the first key will be coord for coordinate, and we'll get its value from our player object, self.player.coord, their coordinate attribute. And then we'll get the three status flags. So is waiting, and we'll do self.player.isWaiting here. Then we'll do is ready, and we'll plug in self.player.isReady. And then the last one is our is playing flag. So is playing. Now we didn't make any changes to this flag, but we will eventually, and we're going to use this function over and over again, so, or method over and over again, so we might as well send it here. So is self.player.isPlaying. All right, so now with our dictionary built, we'll turn that dictionary into a JSON, get a header, and send it over. So let's send the dictionary to the server. All right, so first thing that we'll do is let's turn the dictionary into a JSON object so we can encode it. So player info JSON is equal to json.dumps, and we want to put in our player info here. So now this dictionary has become a string, which is wonderful for us because we can encode that string, we can get the length of that string, all those good things. Let's get the header. So we'll say header is equal to the length of player info JSON. So this will get how big this is, but this is going to be an integer. We want it to be a string, so we can append some white space to it easily. So while the length of header is less than the header length, which is stored in our connection object, so self.connection.header length. What do we want to do? We want to add some white space to our header. So we'll say header plus equals a blank space. This will ensure that our header is 10 characters long, and now we'll send our header over. How are we going to send? Well, we're going to use our connection object, self.connection, and we'll access the player socket of the connection object, .send. What are we sending? We're sending our header, and we have to make sure we encode it. So .encode, and inside of here, our encoder is self.connection.encoder. Awesome. Now that we've sent the header, let's send over the updated player information. So self.connection.playersocket.send. Here we're going to send player info JSON. This is a string, which is great because we can encode it if we spell encode right. And now we'll pass in self.connection.encoder to get our encoder. All right, perfect. So now, if you think about it, each individual client is going to hit enter at different times and be sending in some updated player information to the server. So this means that the server has to always be listening for this incoming message for each and every connected player. We don't know when they're going to come in. Someone might take 1 second to hit enter. Someone might take 1 minute to enter. So this should definitely be run in a thread. So I'm going to save our client file here. I'm going to come back to our server, and if we go to our server and we take a look at our game object's connect players method, which is right here, we're inside of our game object. So game object connect players. If we look here, we'll see that when a player connects, okay, after we broadcast to all players that this player has joined the game, this is probably where we should be listening for some feedback coming back from a connected player. And we want to make sure we do it for every single connected player. player. So here we got to make a thread for this particular player that just joined the game. So I'm going to call this thread ready thread. So if you look at this point, we haven't really made a thread here on the server side. We're accepting any connection, and we're just getting player sockets and player addresses. We're making player sockets. We're sending them over to that specific socket. And right here now, once we've alerted that a new player has officially joined, we're going to create a thread to monitor the ready status of this player. And so to do that, we'll call this ready thread, and we'll say threading.thread. And inside of here, we need a target. So what is our target going to be? Well, we're trying to ready our game, right? Oh, look at that. We've got a ready game method here on the server. Ready the game to be played for a specific player, and that's exactly what we want to do. So we'll target ready game, and we'll make sure we have the arguments of a player and a player socket, which inside of our connect players method, we have a player socket right here. And if we look, we have a player. So this is going to work out really nice for us. So we'll target in our ready thread, we'll target our ready game method, and we'll say args equal, as an iterable, we'll do player and player socket. Awesome. Now that thread has been created, let's start the thread. So we'll say ready thread.start. Awesome. So now what we should probably do is we're starting the ready game thread. We should go write ready game. So let's scroll down to our ready game method right here. We'll get rid of pass, and let's figure out what this method needs us to do. So first in this method, what we're going to do is we'll simply wait to receive the pre-game player information from the given player over the given player socket. So we've got a player and a player socket for this, right? And this is going to be running in a thread for every distinct player and their distinct player socket. So we'll say wait till the given player has sent info signaling they are ready to play. So that means, right, I'll just reiterate this one last time. We're going to broadcast that a new player joins. We send them the information they need for the game window. We send them their player. We broadcast to everybody that this player has joined, and then we start monitoring whether or not they have hit enter to start playing the game. Of course, this client can only hit enter once everybody is in the game, but when that happens, we're just going to sit around and wait for some information to come in, because when they hit enter, that's when our ready game method will run on the client side. We send some player information over, which is going to be our updated status flags. So we're going to just sit here in this thread and wait until we receive some information from the player. Now, if you think about it, we want to receive information from the player here on the server side. We have two specific functions or methods that are going to help us do that: receive pre-game player info and receive game player info. Well, the game has not yet started yet, so we should call receive pre-game player info. So we'll say self.receive pre-game player info, and we'll pass in our player and our respective player socket for the thread that this is running on. Awesome. So maybe we should go and write this method right now. Let's go take a look at it. So receive pre-game player info. If we scroll down, receive pre-game player info. Make sure you're in the right thread here, or in the right thread. Make sure you're in the right method. We want to make sure you're in the pre-game one. We know we're sending over a header, and then we're sending over a player info like dictionary with updated status flags. So let's get the header first, which is going to hold our packet size. So we'll say packet size is equal to. Here we have the player socket that we want to communicate over. So we'll say player socket dot receive. The size is going to be in our connection object. So self.connection dot header length, because this is one of our headers, and we have to decode this. So dot decode self dot connection dot encoder. Awesome. Now we'll get the player info JSON that's going to come in next. So we'll say player info JSON. This is the dictionary of all those updated values. So we'll do player socket dot receive. How big is this packet going to be? Well, it's going to be our packet size. So integer of packet size. I just said packet size, which is kind of funny to me. But if you remember, when we get this, this is going to be a string. So we want to turn it back into a dictionary. So we'll say player info is equal to, we'll use JSON. JSON.loads. And in here we'll pass player info JSON. So this will decode and turn that string back into a dictionary for us. So now we've got a dictionary of updated player values. Well, we've got a player over here on our server end that we need to update for our records of the server. So we should go see, does our, I think our player, so I'm just going to highlight this so we don't lose our spot. Our server player, if we look, here's our player. We've got its initialization. And it's got a set player info method that requires some player information in the form of a dictionary, the coordinates and status flags. So let's call set player info right here, and we'll use this method to update our copy of the player. So we've received some updated player information, so we'll say set the updated values for this player. So we'll do player. We've passed in a player object. And again, this is going to run in a thread for each and every player object. So take this player object and we'll call set player info and we'll pass in the player information. Well, we're calling set player info, so I bet you know what we're going to do next. We are going to go up and write set player info on our server. So we'll scroll up. Here we are inside of the player object. And so let's get rid of the pass. And let's talk about what we need to do inside of set player info. Well, it's pretty straightforward. We have a dictionary, player info, and it's got a bunch of key and values. Let's just go look at what those key values are. We've got on our client side, here it is, send player info. We got coordinate, is waiting, is ready, and is playing. So we're going to update our player on this end. So now, be careful, we are in the player object, right? We're in the player object. So we'll just reference the player as self here. So I'll say self.coord. We're going to update our coordinate attribute is going to be our dictionary, player info, and we'll use the coord key. There's our new coordinate. Self, and we'll do something similar. Self.isWaiting is equal to player underscore info. There's our dictionary, and we'll use the isWaiting key. Self.isReady is going to be player underscore info, and we'll pass in the isReady key. And then lastly, we have our isPlaying flag. So self.isPlaying is equal to player underscore info is playing. Hey, I think that's it. So now when we call that, we pass in some new information, right? Well, we received new information from the client. We received it, we put it into a dictionary, and now we're passing it into the set player info and updating our players' records over here. Awesome. So now that this is all done, I think we can go back to our games ready game method. So if we scroll back down, here is our games ready game method. So, right, we said when someone joins the game, we'll do all that update stuff that we did, prior. We'll create the game player, send it over, and then we'll monitor if this specific player is ready to play. The way we get confirmation is they send us something over. So when they send us something over, now we receive it, we turn it into a dictionary, and we update our player values for this player based off of what just came in. So now what should we check? Well, we should check to see if the players, this particular player's status flags have changed. So we'll say if this player is ready to play. What are we going to do? So if player.isReady, so if that status flag has been set to true, we want to proceed only if all other players are ready. So we'll say while true. We're going to just be in an infinite while loop. So I don't care if this player is ready. I mean, it's important, but what I really care about is all other players being ready. So once we have confirmation that this particular player is ready, we will loop infinitely until we get confirmation that every single player is ready. So how are we going to do that? Well, we'll just say check if all players are ready. We'll create a Boolean variable. We'll call it I don't know, what do I want to call it? I'll call it game start, and I'll set it equal to true. And what I'll now do is loop through all of my player objects that are connected to the server. If you recall, the game object here on the server has a list of all of these player objects. So I'll say for player object in self.player underscore objects. I'm just going to scroll up to show where we define that list. I know it's been a while. In our game's initialization method, we have two lists that help us here, player objects and player sockets. And so every time we create a new player, here's our connect player method. Every time we create a new player, we append that player to this list. So we've got a list of those. So we're going to loop through each and every one of these player objects. And what do we want to check? Well, we're going to look to see if one of those players is not ready to play the game. So we'll say if player object dot is ready, if their is ready flag is equal to false. So that means if one player is not ready, then the whole game is not ready to play. So we're going to take game start, this Boolean that we just defined, and we'll set it back to false. However, if we loop through every single player in our object or our list of objects, player objects, and not a single one is not ready, then that means every single person is ready to play the game and we should advance. So outside of this for loop, I'll say all current players are ready to play the game. I'll say if all current players. And so how are we going to signal this? Well, we're going to say if that game start variable is still true. So if game start, then we'll take this particular player, and we'll set its is playing flag to true. And this will happen in all of the threads because, remember, ready game is running in a thread for this particular player, so we're only going to set this particular player's flag to true. And for right now, I will print a visual confirmation on the server. We'll say playing the game. And now, if we're going to play the game, we're going to start the game. It's important to mention that we said the timing aspect of the game is all going to be done by the server. The server is going to keep track of time and then push that time out to each individual client. And I think that's the better way to do it, because if we keep track of time locally on each individual client, well, there could be some issues because certain games might run faster than others and the times might not be synced. And that would be really bad, like if one game finished but another game was still going on. So we'll start a clock on the server for the game. And so to do this, we're going to create a new attribute. We're going to call it start time, so self.startTime. The time where we started playing the game, we can use the time module. If you recall, we imported the time module. And so we'll use the time module here. And we'll say time. We'll call the time method. So this will get like the process time, like a computer time, and I think it's in like seconds since the dawn of something. I don't know. It's a weird number. I'm not fully sure. But it gives us a time that our computer can reference. And so we'll start it now, and then what we'll do is we'll check what that current time is, in different iterations of our game loop, and we'll just subtract the two to get how much time has essentially overlapped. Now that the game has started, what we can do is we can break out of this infinite while loop that we were running, and we'll move on to the next part here. So I think this is going to work pretty nicely. Let's actually test this now, and let's see how this works. So I'm going to run the server. So the server is starting. I'm going to have one person connect. So they connect, they get all of the gameplay information from the server, they create a window, all right, and it looks like I have an error here. Ready game is not defined. So this is in my server file on line 158. Did I forget? Oh, I'm on my client. Silly me. On my server file on line 158, ready thread is equal to threading.thread target. So I targeted ready game. That's a big mistake here because ready game exists inside of the game class. And so how do we show that this method is attached to our game class? We need the self keyword. So I forgot self.readyGame right here. So a quick fix. Hopefully that is our only error, but our this program's getting pretty large in scope. So we're going to get errors, we're going to make mistakes, and we have to learn how to debug them. I think it's a good skill. All right, so here is our first game window. Perfect. So we connected to the server sent over our game configuration, we built a window, the server sent over a player object, we built the player object, and now we're sitting here just waiting for everybody to join. If I run it again, we're going to do the exact same thing, except now, if we look, we have our maximum number of players. And so really what we have just done is on the server, we have 2 threads running right now. A thread listening for confirmation from our first player, player 1, and our thread listening from confirmation from our second player, player 2. And so let's hit enter. Let's see if I hit enter. All right, so that's great. The status message has changed to ready, waiting for other players. And so now I'm going to hit enter here. And it says ready, waiting for other players. And if you notice, we've got no visual feedback that the game has begun on the client, but look at our server. It says playing the game, playing the game. So that means this is working out perfectly, because if I come over here to my server, what's the last thing we had it do in that ready game thread that we were starting? Well, while we were waiting for everybody to join the game, everybody joined the game, everybody's is ready flag became true. We said print this status message and then break out of the loop. And so it did that for both of those. It broke out of the loop, and then it eventually said, hey, maybe this server's over because there's nothing else for us to do. So everything up to this point is working awesome. What we now have to do is push this information from the server that the game has started back over to the clients to trigger the start of the game on their respective machines, which is exactly what we'll do in our next video. So I'll see you then.